Hello, everyone. Welcome to today's live broadcast, Key Buying Factors for Tubing Used in Biopharmaceutical Manufacturing. I'm Shannon Stoltz, Senior Editor of Special Projects for BioPharm International, and I'll be your moderator for today's event. We are pleased to bring you this webcast presented by BioPharm International and sponsored by ILC Dover. ILC Dover is a world leader in the innovative design and production of solutions for biotherapeutic, pharmaceutical, and medical device markets, as well as a leading supplier for the aerospace industries. Its customers will attest to the company's relentless dedication to high-value products, advanced technology, and responsive services. ILC Dover's visionary solutions have improved efficiency while safeguarding people, product, and infrastructure in hazardous conditions through flexible protective solutions since 1947. We have a few important announcements before we begin. This webcast is designed to be interactive, and we encourage you to ask questions during the event. You can submit questions by typing them in the Q&A box, which can be found at the bottom of the video player. You can enlarge the slide window by clicking on the small icon in the bottom right corner of the media player. The slides will advance automatically during the event. If you have any technical problems viewing or hearing this presentation, please click on the question mark help widget in the top right of your presentation window. I would now like to introduce today's speaker. We are pleased to be joined today by John Litz. John Litz is a business development manager at ILC Dover, who has 10 years of experience in the bioprocessing space in both production and commercial roles. He obtained his degree in biological sciences from Salisbury University in Maryland. He began his career with Lonza Scientific shortly after graduating, and since 2015, he moved into a commercial role and has held various responsibilities in business development, product management, market research, and single-use fluid transfer assembly design. Thank you so much for joining us today, and please get us started.
All right, thank you, Shannon. I really appreciate the introduction, and I guess I'll get started now. So the main goal here of this presentation is essentially helping everyone here choose the right tubing for their process. So let's get started. Choosing the right tubing. So tubing is much more than just a piece of plastic that you utilize within your process to move fluids, right? So there are various materials that can help. Really help you be successful in your process, and those materials aren't just standard plastics, right? You might have silicones, you might have TPEs, you might have different types of thermoplastic rubbers, but all tubing is not going to be the same. Every application calls for a different type of tubing to ensure success, right? And the right tubing can really make or break your ability to maintain a closed system and help your assemblies from leaking, because leaks in the end, when it comes to tubing, are not what we want. We want to make sure the system maintains closed so all that bulk drug product can be recovered and ultimately then moved forward in the final fill for vials. So moving forward, some of the typical applications where you might see tubing in bioprocess. Generally, if you're going to be starting upstream, you'll be looking at your cell culture and expansion. Generally, this is done with smaller size tubing. As you're going to be doing scale up, your tube will continually increase in size generally as you move to larger vessels. And again, moving forward from cell culture and expansion, you can have different types of tubing in your production and harvest systems, whether that be a standard unreinforced tube or a braided hose. With filtration and chromatography, given their higher pressure applications, you're most likely to see some type of braided hose. Generally, those are going to be silicone. Buffer and media preparation. Generally, this is just going to be your standard fluid transfer. There may be some pumping going on there, so you might need to specialize tubing for pumping. And then again, in any type of single-use fluid transfer assembly, right? And those can be bioreactor kits, they can be assemblies for tangential flow filtration, or they could be final fill assemblies with pump tubing, filling needles, etc. Tubing also is very, very closely integrated into bag manifolds for storing bulk drug substance. And again, touching on filling, smaller tubing used in sampling, and then again, as well in process development and laboratory use. Here's just a quick graphic on where tubing might be used in your process, right? So you can see upstream here, you're going to be starting with your cell seeding, cell expansion. You're going to be adding media. That's all going to be happening with tubing. As you move from your wave bag or your storage bag to your bioreactors, you'll see scale up, where you'll use different sizes of tubing potentially, depending on the size of the reactor. Moving forward, if you're using specialized single-use centrifuges, I know Car Bioscience makes a great single-use centrifuge with tubing assemblies. You might have something directly attached for your centrifugation, moving forward to your filtration applications in the downstream area. Now in downstream, you'll have higher pressure applications for your filtration and chromatography. And in those different applications, you're going to be seeing buffers added. You're going to be seeing a lot of different types of tubing, whether that be, again, specialized pump tubing for continuous processing applications, braided hose for any type of high pressure application utilizing magnetic flow head, pump heads, or even just sometimes general unreinforced tubing, whether that be silicone or TPE for different types of applications. Say in TFF, you have your permeate and retentate lines. That's where you might see something that's unreinforced. Moving through TFF to bulk formulation, you'll generally see your standard unreinforced tubing there as it leads into final fill, which you would have some pump tubing in an assembly with your filling needles, which would go into an isolator and do the final fill into your vials. What are some of the physical considerations for choosing the right tubing? One of the first things that you might think of when it comes to tubing is the tubing hardness, right? And that's represented by durometer. So the general measure for durometer is going to be what is called Shore A. There's also Shore D, which is generally used on more rigid tubing like a fluoropolymer. But Shore A is primarily what you're going to be seeing in the bioprocess industry. So when we say a tubing is a 50 durometer or 50 Shore A, that's going to be softer than something that's going to be an 80 Shore A durometer. And within applications, within different applications, you might need a higher durometer or a lower durometer, just depending on what you're doing with the tubing, right? So if you're going to be doing higher pressures, but not something that requires the pressure requirements of a braided hose, you might use a product that is a higher durometer, like an 80 durometer, because it can withstand higher pressures than something like a 50 durometer. If you're going to be pumping, you're generally going to see tubing in that 50 Shore A to 60 Shore A durometer range. And again, with that being said, durometer is something that's very important to pay attention to because it can affect the outcome of your application. It can affect the success of your tubing in your application. And again, I had mentioned pumping. Generally, in those cases, when you're choosing a tubing, you're going to want to make sure that the durometer fits into what you're looking for and that the durometer is not too high, because at very high durometers, you might be more likely to see a split in your tubing during pumping. Moving forward, some of the next physical considerations you might have are tensile strength and elongation. So tensile strength essentially is just the max stretch before the tubing will snap or break. And elongation is the change in length after force. So if you're pulling on that tubing, how likely is that tubing going to stay at the new length from the force that was applied? So touching on deformation of tubing, next we're going to be moving to modulus and compression set. And modulus is the resistance of deformation from force. Modulus can be very important for pump tubing applications because you're going to want to make sure that it has a good resistance to deformation. One thing that you'll commonly see in pump applications is tubing compression. And essentially, when you think of tubing, you think of a circular inner diameter of the tubing that helps maintain consistent flow rates. And in certain cases, if you have a tubing with an inappropriate modulus or compression set, you might see ovality occur on the tube, which can affect flow rates and it can affect the success of the tubing in a pump application. Now, moving forward, the next thing that you're going to be looking into, especially if you're doing pumping, is pump life, right? And that's pretty self-explanatory of how long will the tubing last in a pump before failure? And that's definitely something that is going to become more important as we see more applications like perfusion continue to rise on the market, where sometimes specialized pump tubing can be necessary that has pump lives anywhere from 1,000 to 10,000 hours. Another that I actually don't have listed here is spallation. And that again goes kind of into pump applications, right? So spallation is particle shedding. And it can happen if you are seeing continuous hits on your tubing from your roller head pumps. Choosing a tubing with little to no spallation is going to be preferable so you don't have tubing particles ending up in your drug product. Next, we are going to be looking into pressure ratings. So why is pressure important? Understanding what your pressures are is extremely important to your application, because if you're running pressures that are too high for a standard unreinforced tube, you might have leakage or you might have tubing rupture. Now, with higher pressures, again, there are special tubing available, special hose available that generally have braid reinforcement to ensure that that tubing can withstand your high pressures. If you're running at low pressures, you can just use a standard unreinforced tube without much of an issue. And lastly, shelf life. So shelf life is just going to be your life of the tubing pre-use. And that can include both gamma irradiation shelf life or your standard shelf life. And in most cases, what I've seen in the industry, generally, you're going to see a shelf life on silicone tubing of anywhere from 3 to 10 years, with the general average being around 5. Post gamma, more likely you're going to see a shelf life of 2 to 3 years. On to tubing size. So this is something that might not be on the forefront of your mind when you're initially looking to choose your tubing. You might be thinking of materials, you might be thinking of essentially what your process is, but picking the right size of tubing is going to be integral. It's going to be very important essentially when you're looking to integrate your components of choice into your assembly with your tubing, right? So tubing size is not just important to your choice of connectors and your choice of filter, essentially. It can affect how your process moves forward, right? So utilizing a smaller size tubing, you're not going to have the same flow rate as you would have with a larger size tubing. And that, again, can increase or decrease your flow rate and have an effect on your filling speed. Now, some of your typical sizes you might see, and there's going to be multiple offerings that I don't have listed here, but some of the more common that you might see are going to be 1/8 inch, 1/4 inch, 3/8, 1/2 inch, and 1 inch. And again, those all have their place in different areas of the process. For 1/8 by 1/4 inch, if you're going to be doing any type of sampling, generally you might be using a small sampling port on a smaller size tube. If you're doing pumping upstream where you're doing scale up, you might see something like a 1/4 inch ID or 3/8 inch ID used. And then as you get further in the process, when you're doing larger volume fluid transfer, you'll be seeing a larger volume ID tubes, of course. So you'll be seeing more of those 1/2 inch or 3/4 inch or 1 inch ID tubing. Another important thing to consider when you're looking at size is the actual size number. And sometimes this might not be so straightforward, right? So in certain cases, when you're utilizing a pump, you might have a certain roller head number, right? And your tubing is going to be, the tubing size will essentially be very important to ensure that you have the right tubing in that correct pump head. So I've listed some of the sizes here, and you can see size 16, size 24, 73. These are 3 of the more commonly used sizes in pump applications, as well as other types of applications in your upstream and downstream process. Choosing the right materials. I touched on this briefly in the beginning of the presentation, but when it comes to choosing the right material for your application, it can really be a make or break factor in how successful you can be when you're running anything upstream or downstream, right? So generally, when you're thinking of the more commonly used tubing in the industry, you're probably going to be primarily thinking of your silicones or your TPEs. And TPEs are more of a thermoplastic, whereas silicone is going to be a thermoset material. But silicone has been around in the industry for quite some time. It's definitely the essential tubing of choice. It's one that you'll see very commonly used throughout all areas of the manufacturing process. And that is just because of its proven industry success. Also, it is a very versatile offering. It has great chemical compatibility. Really, it's very durable in formulation. And there are multiple formulations on the market for various applications. So silicone tubing might not just be for general transfer. You can also have pump formulations for silicone. You can have reinforced silicone like a braided hose, which I'll be touching on later. You can even have temperature specific formulations for different types of applications like cold chain storage. Moving forward from silicone to TPE, probably the two most notable TPEs on the market at the moment are going to be your C-Flex and your Advanaflex. And sometimes even when people might be looking for a TPE, they might specifically be asking for something like C-Flex or Advanaflex because they are such industry leaders here. But in general, your TPE is going to be a thermoplastic elastomer tubing, right? And one big difference between your TPE and your silicone, given that your silicone is a thermoset material and your TPE is a thermoplastic, you have the ability to manipulate the TPE with heat where you wouldn't with silicone. And that being said, one of the primary applications that you might use TPE for is going to be any type of aseptic sealing or welding. This is definitely a great use case for TPE, especially if end users don't want to use costly aseptic connectors and they have welding capabilities or sealing capabilities for disconnection and connection. TPE would be the right choice there. Certain TPEs on the market now also are being specially formulated for pumping, and some of those TPEs can last 1,000 hours or more. Again, pump life is definitely something that can be a big influence when choosing your tubing, so it's important to recognize that you need those types of physical requirements when choosing your tubing. And lastly, for TPE, just chemical compatibility. And I've listed chemical compatibility on the TPE side instead of silicone, just because with the different materials, they are going to react differently to different chemicals. And in certain cases where silicone might not be the right choice, TPE also may have different chemical compatibility ratings with different types of chemicals you might be using, whether those be caustic, acidic, either way. It's important to ensure that you have good chemical compatibility on your tubing to make sure that you're not having any degradation of your tubing in process. Moving on to PVC. So PVC is something that's been more so phased out of the bioprocess space only because it is kind of viewed as a lower purity material. And generally one of the reasons for that is some TPEs use different things like plasticizers, which are nasty and we don't really want them in any type of bulk drug substance. And they can definitely be extracted or leach into the product fairly easily. But PVC again is a legacy material in the industry. It's not as commonly used as it once was, but it is commonly used still in some lab areas in process development. And one of the main benefits of PVC is that it's going to have the lowest cost. I think we all know though that cost isn't necessarily the be all end all there. And in the majority of cases, having a high quality tube for your process is going to be more important. And that's one of the reasons why people are more likely to use a silicone or a TPE. Moving on to some specialty formulations, there are formulations on the market that are different than the silicones, TPEs, et cetera. And those you might see listed as a TPV, which is a thermoplastic vulcanizate, or a TPR, thermoplastic rubber. These are generally used for pump applications. And one of the reasons why they're excellent for pump applications is because in certain cases, they have pump lives up to 10,000 hours or greater. These products also tend to have fairly good chemical compatibility ratings. And when it comes to pump life, it's going to be far superior to your general silicones that you might use for general transfer. Composite materials are also something you might commonly see on the market. And here, the main example that I'm thinking of is going to be a Stay Pure tubing. That is, again, a specialty formulation that can withstand very high pressures with little to no particle shedding or spallation in process. And again, it's going to have ultra long pump life of 10,000 hours plus. And some of the ways that they might be manufactured, composite materials or Stay Pure for this example, is if you're utilizing silicone and a PTFE, the PTFE would be essentially done via scaffold, and then the silicone would fill those gaps, ensuring that that composite material is made correctly. There's going to be a really great use case in pumps. There's going to be very high pressure tolerances for any type of very critical application that you're going to be running pumps for a very long extended period of time. On to temperature specific formulations. So these have been popping up over the years as we've seen more use of cold chain in supply chain. So these are generally specialty formulations for cold storage or for refrigeration, freeze thaw, et cetera. And one of the benefits of these formulations is their ability to handle low temperatures without compromising the physical integrity of the tubing. So in certain cases, tubing might be the weakest link in a freeze thaw application. You might be worried about the tubing snapping or cracking. With certain specialty formulations like this, they can handle that freeze thaw without having any issues with bending. The tube will bend back into its normal shape. You won't really have issues with the tubing being crushed in storage. You won't really have those issues with the tubing snapping or cracking. And that is one of the reasons why some of these temperature specific formulations can be a very good product if you are going to be doing that type of cold storage or very low temperature storage. Now moving forward to hoses. So there actually is a difference between tubing and hose. And the difference there is that essentially hose is just a reinforced tube. The way that they're manufactured is also a bit different. You might see tubing described as a one-pass process. So when the tubing is manufactured, it goes through the extruder. An unreinforced tube with no reinforcement would then be able to be inspected, coiled, bagged, and put out the door, essentially in one go. With a reinforced hose, the way that that's manufactured is you extrude the inner liner in a similar fashion to the way that you'd extrude an unreinforced tube. That inner liner is then placed on large, generally stainless steel spools, run through a braiding machine that puts the braid reinforcement on the hose. And then it's passed through the extruder again to essentially seal the braiding in and provide that outer jacket cover on the tube. Right, and that's just some of the differences how they're made. But when it comes to braid reinforced hose, there is different use cases for the braid reinforced hose in comparison to an unreinforced tubing. And generally you're going to see these made with silicone, but in certain cases you will see other materials used. There are braided TPEs on the market, and generally those can be subbed in for silicone when there's chemical compatibility issues. But these are primarily used in high pressure applications, and one that I commonly see that's used, braided hose used in, is tangential flow filtration applications or any type of really downstream filtration applications where very high pressures are needed to kind of push your material through those filtration membranes. Moving on, if your braid reinforced hose isn't going to handle the pressure requirements that you're seeing, you might look into something that's going to be a wire reinforced hose. These are durable, very durable hoses that generally have a wire reinforcement as well as a fabric reinforcement. Also generally made from silicone, but they are available in a great deal of materials, whether that be for the bioprocess industry or other industries like food and beverage, brewing beer, etc. But generally, these types of hoses have a very large inner diameter with that wire reinforcement for high pressure bulk fluid transfer. And whereas you might see a braided hose with an ID of anywhere from an inch to an inch and a half, wire reinforced hoses might go anywhere from 4 inches, even all the way up to 6 inches in some case. But again, these are generally hoses that aren't going to be considered single use. In most cases here, you're going to be autoclaving the hoses after initial use and then reusing them in process. So moving forward, just to touch on one last reinforced hose that you might see used, fluoropolymer. So fluoropolymer is a material. It kind of is broken into some different subsets. You might see PTFE used, you might see PFA used, you might see FEP used. Those are all fluoropolymers. And one of the very useful benefits of fluoropolymers is they are very chemically inert. So if there's any type of major issues with chemical compatibility and you can't use silicone or TPE, fluoropolymer hoses might be the best choice for you. And again, generally they can be used in chemical transfer, whether that be caustic or acidic chemicals, fluoropolymer is definitely going to be the way to go due to its chemical resistance properties. And some of the quality requirements you might require on your tubing. Generally, industry-wide, there is going to be a lot of overlap when it comes to what is tested, and these are just regulations essentially that ensure the tubing is pure, good for use, and there's not going to be anything getting into your bulk drug substance throughout the upstream or downstream manufacturing process, right? And some of the main things that you're going to see is biocompatibility testing. That's generally done to the ISO 10993 method for biological reactivity in medical devices. And the ISO 10993 is actually a series of multiple tests. So there's actually, I believe, 20 or more tests that make up that ISO 10993, not all of which apply for tubing, but it is a very rigorous series of tests that this tubing needs to undergo to ensure that it's going to be safe for use in the drug manufacturing process. Some others that you might see are USP tests. USP stands for United States Pharmacopoeia. And more than likely, the most common that you might see is USP Class 6. That is a biological reactivity test, similar to your biocompatibility testing. And that regulation is going to be Chapter 88 from USP. Another biological reactivity test you're going to see sometimes in conjunction with USP 88 is USP 87. But then there are also additional tests that are generally done on your finished product, like testing for endotoxin. You don't want any endotoxin or endotoxic or cytotoxic tubing, that's for sure. It would affect your overall product viability and product yields. Moving forward from there, though, you're going to have 661, which is packaging and materials of construction. Essentially, that's just ensuring that the material used in the tubing is going to have very high purity. 381, which is testing for elastomeric closures, and then USP 788, which is particulate testing. So all of those are going to be done on ILC Dover tubing. You'll also see those types of tests on a lot of commonly used tubing within the industry. Moving forward, we have EP, which is similar to USP, which is United States Pharmacopoeia. EP is European Pharmacopoeia. And there is some overlap here in certain cases. You can have a cross, like where if you were able to get testing completed in one area, you might be able to get that also. Say you have USP testing completed, you also might be able to utilize that to leverage a completion of your European Pharmacopoeia testing. And generally, the three most common that you're going to see in the industry is 3.1.9, which is generally used for testing silicone closures and tubing. 3.2.9, which is elastomeric closures. So that might be used on silicone. It might also be used on TPRs or TPVs. And then the 3.2.2.1, which is plastic containers. So you'll generally see that 3.2.2.1 on any type of thermoplastic elastomer TPE tubing. It's also very important that your supplier have good inspection procedures when it comes to tubing extrusion. So you're going to want to make sure that there's some kind of inline sampling done to ensure the tubing is within its specified tolerances, ID, OD, length, wall thickness, etc. Visual inspection for any type of particulates, right? So at ILC Dover, we do 100% visual inspection over a light box. So our operators can see that there is no visible or subvisible particulate in the packaging or in the tubing itself. Next, and arguably the most important thing that some people look into when it comes to choosing a tubing is going to be your extractables testing. And there are two primary tests essentially that people utilize when it comes to doing their extractables testing. And this essentially just comes down to the user as to which you might want to use. But you have your Bioform Operations Group or BPOG testing, and then your United States Pharmacopoeia 665 testing. BPOG is very in-depth, so it's going to be 6 solvents over multiple time points, and it's more of a one-size-fits-all approach for different components in the industry, whereas USP 665 focuses on 3 solvents at individual time points based on the risk of the component. So if the component is labeled high risk versus low risk, it would have different set time point with those 3 solvents. Physiochemical testing essentially evaluates the purity of the material itself and containment materials and contaminants. So certain things there you might see like specific gravity. Again, modulus is a physiochemical test. And then moving forward, you have, you need to make sure the tubing is animal-derived ingredient free, and this can be done with EMA 41001. But essentially, you want to make sure that your tubing has no BSE or TSE contaminants inside of the actual formulation. So this is something that's also very commonly certified for tubing in the industry. And the last two I'll cover at the moment are gamma stability and then your clean room certification. So in the case that you're looking for gamma irradiated tubing or sterilized tubing using gamma irradiation, you're going to need to ensure that the tubing will not have any degradation in the gamma irradiation process. And in most cases, tubing is irradiated at 25 to 40 or 25 to 45 kilogray. However, most tubing on the market is actually tested to 50 kilogray to ensure that there's not going to be any issues with it in that general standard range that you might see from the Steris or Sterigenics. And lastly, clean room certification. So in general, you're going to want to make sure that your tubing is clean room extruded. You don't want to have a tubing that's extruded in a garage, obviously. But when it does come to your tubing, you need to ensure that it's in a clean space that works for your process and it helps you mitigate any type of risk, right? So in general, what you might see is an ISO class 7 clean room. Certain products might be made in the ISO class 8. However, ISO class 7 is generally the standard for any type of bioprocess component manufacturing. So choosing a supplier, how does one go about choosing a supplier when there's so many different manufacturers, distributors on the market, and tubing is becoming more of a commoditized item? Right? It really depends on what you're looking for. And in certain cases, if you're running a full process and you're looking to develop a full process with hardware systems, with bags, with other components, it might be best to choose someone like that. Might be an end-to-end solution provider that can provide all of those items that you're looking for as you develop your process. In the case that you might have issues with certain types of tubing in your application and you're looking for different formulations for different specialty applications, you might want to look for someone who has a lot of experience with tubing and does have those various formulations of silicones, TPEs, TPRs, TPVs, and braided hoses available. Those can generally be bought from manufacturers or through distribution. Definitely one thing for me that I have seen, if you're going to be utilizing smaller quantities, utilizing distributors might be the way to go, whether that be someone like a Cosina, someone like a VWR, or even more local distribution channels within a certain region. If you're going to be buying smaller quantities, distributors in the area are great ways to go because they can provide on-site support as well as sometimes more favorable pricing on the smaller quantities than you may get from a manufacturer or end-to-end solution provider. Now, for quality systems, what you might need from your supplier is definitely a validated quality process. And in most cases, you'll see that done to ISO 9001 or ISO 13485. ISO 13485 was more so initially for medical device. However, given its stringent requirements, more people in the bioprocess industry have been moving to that 13485 quality regulation. And again, I touched on this on the last slide, but it's very important to ensure that your supplier has, if they're manufacturing product, has certified clean rooms, generally to ISO class 7. You also want to make sure that the tubing is produced and packaged in those clean rooms. Generally, all products should be double bagged. It should not be single bagged unless there's not going to be transfer into a clean space. The product should be double bagged just so that when you're doing transfer, you can remove that outer bag to ensure there's no particulate going into your clean space with the tubing. Now, all product also needs to be lot traceable. If there is a failure, or if there is some kind of issue with the tubing, it needs to be understood what lot of tubing that came from. So if there's a necessity to do a recall, that can happen. And lastly, a validation guide. Validation guides are very important from an end user standpoint to help spec tubing in. It just essentially lists everything that's needed in one place, one centralized location, where the information can be easily accessible to the user. Next is location. You're going to want to make sure that you choose a manufacturer of tubing that's in a location that's convenient for you, that's also a very trusted place manufacture, right? So if you're in North America, you might be looking for a North American manufacturer. If you're in Europe, you might be looking for a European manufacturer. It really can all just depend geographically where you might be located. Number of sites is another very important thing to consider when you're looking at a supplier. And one reason for this is just in case there ever is some kind of force majeure and a site is forced to close down. Having multiple sites with redundant manufacturing capabilities is extremely important to ensure that users of the product are going to be able to receive that product and there's not shutdowns due to any types of force majeure or some other any other types of things that might happen that would cause supply to shut down at one site. Reliable supply. So I think one thing that a lot of integrators, end users, manufacturers, everyone kind of experienced over the course of COVID were issues with supply chain. Now, one of the common things that we saw there were inconsistent delivery dates that were moved up, moved back, really moved all over the place. And with that being said, if delivery dates are not consistent, it can really affect user planning to run a campaign. So ensuring that a reliable supply is there, ensuring that you have consistent delivery dates is extremely important from your supplier, just to ensure that you have everything that you need as a user to ensure that your process is planned correctly without having any hiccups from supply chain. And lastly, price and lead time. It's very important that when choosing a supplier, you make sure that you can get a price that's favorable to your own specific needs and lead time. I think everyone wants product as soon as they can get it. And that's another thing to choose your supplier with is if your supplier has very long lead times, they might not be the best supplier for you at that time, just because you might be able to get a similar product or a product that works in the same way from someone else much more quickly. And this is just an example of ILC Dover, how we have multiple sites to ensure reliability of supply, right? So over the course of the last many years, we've made many strategic acquisitions, one of them being Flexan. And Flexan has been a leading tubing extruder in the medical device industry since their founding in 1946. But just as an example, we do have a Salt Lake City site here, which is primarily where we do all of our TPE extrusion. We have 2 extrusion lines there. Lincolnshire, which is primarily where we do all of our silicone extrusion. We do have 5 extrusion lines there. And then Juarez, Mexico, which is going to be our new site. We have the availability to put in redundant manufacturing capability there. But again, just ensuring that your supplier has multiple avenues to manufacture product and get the user product, it's very important for that reliability of supply. Great, and that's the end of my presentation. So let's open it up now for any questions.
Thank you so much, John, for that informative presentation. Before we get started on the question and answer session, I would like to remind our audience how to submit questions. You can submit questions by typing them in the Q&A box, which can be found directly below the video player. So our first question is, can you elaborate on differences between the extractables testing?
Yes, so the 2 main extractables tests that I mentioned previously are going to be your BPOG, which is Bioform Operations Group, and your USP 665, which again is United States Pharmacopoeia. And essentially USP, United States Pharmacopoeia, is going to be what is your public standard for drug manufacturing here. Whereas Bioform Operations Group is not necessarily a public organization, but it's a group of the largest players in the industry coming together to say, hey, we need this, 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 and that for our risk mitigation for extractables testing. And again, that is generally 6 commonly used solvents throughout upstream, downstream manufacturing, used over various time points up to 70 days. And that is definitely anything that you might see long-term storage. That's generally when you're thinking of time points that are out that far, you might be thinking more so of a bag or a bottle, more so in comparison to a tubing, which you might see better representative data from a shorter time point. Now with USP testing, there are 3 solvents, 3 commonly used solvents over single time points based on risk for the overall component. So higher risk process components like tubing, might have different sets of requirements or different time points than something like a bottle or a bag.
Thank you. And can you do the same for differences between TPE and silicone?
Yeah, so the major difference between TPE and silicone just comes down to actual material properties. And silicone is a thermoset material. So when it's extruded and sees the heat, it's formed into its tube after passing through the die. It will essentially take shape and it cannot be changed from that shape. Silicone generally also has a higher temperature rating and lower temperature rating than your TPEs would, but TPEs, because they are a plastic, can be molded in various different ways. Most commonly, you'll see heat welding or heat sealing done for aseptic connection and disconnection in place of aseptic connectors that you would need to use on a silicone tubing or other type of thermoset material.
Thank you. And how would you respond to someone wondering what material to choose for their tubing?
Well, it really depends on application. If you're going to be pumping or running a perfusion process for 90 days, you're going to be wanting to use something like a TPR or TPV. There's some great brands on the market there, one being a PharmEd BPT. And that product itself has a pump life of, I believe, up to 10,000 hours. So if you're running a 90-day campaign or a 45-day campaign, something that's going to be longer than standard 10 to 14 days, you're going to need a specialty pump tube for that. If you're going to be just doing general transfer, silicone might be fine. TPE also could be fine. It just depends on certain things like your pressures, your temperature requirements, your chemical compatibility requirements, and ultimately your application specifics.
Great. On to our next question. How do you prevent a tube from kinking?
So this is something that I've seen commonly happen on bioreactor tubing kits. Essentially, if you have a filter within a tube, if the wall thickness, the wall might not be thick enough. If you're using a thin wall tubing, you might see the weight of that filter kind of collapse that tubing and kink the tubing. One major issue with that is if you are experiencing kinking in your tubing, whether that be fluid or for venting, you're not going to have the proper flow rates necessary to have your process performing at optimal conditions, right? So there's a couple things that can be done to help prevent kinking. Some of those being utilizing a tubing with a greater wall thickness, especially on something like a bioreactor kit. A tubing with greater wall thickness is going to be able to support a component like a filter in a much better fashion. It's something that's very, very low wall thickness. Another thing that you can utilize if you're having issues just during general transfer, if you're looking to bend your tube, there's products on the market essentially that act as like an exoskeleton for the tube called flow bend clips, and those can help prevent kinking by essentially just holding the tubing in essentially a rounded shape through that elbow or other direction that you need to make sure that the tubing isn't going to collapse on itself as it's manipulated.
Thank you. And on to our next question. What causes spallation or pump tubing failure?
So spallation can be caused by a couple things. That could be caused by material. If the material is not up to par for a pump application, you might see spallation earlier in the process. Certain times spallation could be caused by extended use in a pump. And that essentially is just because of the pump roller heads consistently making contact with the tubing, stretching the tubing, and then having the tubing return to normal form. It can cause that particle shedding on the external diameter and internal diameter of that tube. When it comes to pump failure, generally where you're going to see pump failure is if you're using incorrect size tubing. If you've pumped the tubing for too long, you might see a rupture. In certain cases, material might cause you to have a rupture. So if you're trying to utilize a peristaltic pump with a braided hose, the braided hose will actually delaminate and you will have a failure in your pump.
Perfect, thank you. So it looks like we have time for one more question. What happens if someone picks the wrong tubing?
So luckily enough, there is a lot of overlap for tubing. And in most cases, tubing is just used for general fluid transfer. So if you're utilizing a silicone for general transfer, as long as you're not going to have any issues with chemical compatibility or pump life, you should be able to use a TPR, TPV just fine. The only places that I would be really concerned for using the incorrect tubing might be for extended pump life applications, high pressure applications, temperature specific applications where you might need to ensure that you're not going to have any cracking or issues with your tubing. Or any area where you might need to manipulate your tubing in certain ways, like if you're utilizing, I guess kind of what I mentioned earlier with kinking, you're going to want to make sure that you have something that has a little bit more wall thickness so you can ensure that it's not going to collapse in on itself. But thankfully, ultimately, in many cases, you can get away with a little bit of overlap with your unreinforced tubing.
Great. Thank you so much for your time today. With that, it looks like it's already time to wrap up. I want to thank the audience for attending and participating in today's event. And I would also like to thank our sponsor, ILC Dover, for making today's educational webcast possible. We would like to ask everyone in the audience to participate in a brief survey, and the survey will appear on your screen after today's presentation has ended. You'll receive an email alerting you when this webcast will be available for replay, and we invite you to forward that announcement to your colleagues who may have missed today's live event. We hope to see you all next time. Thank you and goodbye.